All right, greetings everybody, and welcome to our webinar today. Um, I think for the sake of respecting everyone's time, we're going to jump right in. I see you all should have a brief poll pop up right now, so we can just get a sense of where everybody's coming from. But other than that, I'll jump right in. So welcome to our webinar today, Sidewalk Data for Detailed First and Last Mile Access Analysis. We're very excited to be welcoming folks from the state of Washington today, the Washington DOT and the University of Washington. Um, and also, before we get into things, just wanted to say a special thanks to our friends at Conveil, which is an accessibility analysis platform, for reaching out and sort of kicking off this webinar today, which we're really excited about. My name is Chris McCahill. I'm the managing director of the State Smart Transportation Initiative, SSTI, which I'll tell you a little bit more about in a second. And we've got my colleague, Eric Murphy, helping run the show behind the scenes today. Just a little bit of housekeeping before we get started. A recording of this webinar will be available maybe tomorrow, but definitely this week. And we will have time to take some questions at the end, hopefully. And so at any point during the presentations, feel free to drop your questions in the Q&A box. I believe the chat will be disabled, but we'll be looking at that Q&A. I know many of you are probably new to our organization, SSTI. So just a little intro to what we do. We work with state departments of transportation all across the country. We try and find the most forward-thinking leaders and staff and help them move the agency into a more innovative next generation. All of our work is rooted in our core values, which are sustainability, equity, and transparency among state DOTs. And we work in three main ways. One is through convening. So we host an annual meeting for leaders of state DOTs. We host peer learning networks for staff. The second is through knowledge sharing. That is our newsletter, policy briefs, and webinars like this today. And finally, in building capacity. And we do this mainly through technical assistance and workshops with DOT staff. So before we hand things over to our speakers today, I think I will share the results of our survey, I think, because most people have probably trickled in. We can see a lot of folks, good distribution across the country. So I'm glad to see everybody joining us. Our topic today is pedestrian networks and accessibility analysis. Accessibility analysis is something that we've been working on with state and local agencies for quite a few years now. This is measuring access to opportunities by driving, transit, biking, and walking. So basically asking the question, can people get where they need to go by the modes that are available to them? Many of you are probably familiar with this. I know our friends in Washington will be talking about this a little bit more. But the really key part that we're focusing on today is pedestrian networks. And you can see in this slide here, what we often do in accessibility analysis is rely on the centerline network to model travel behavior, even when it comes to walking and biking, right? Centerline networks are very useful in modeling driving, less so in modeling active transportation modes. So what we're trying to do here is move from the figure on the left to the figure on the right, where we can overlay a very detailed walking network on top of the driving network. That lets us model whether or not there are sidewalks on one part of the road versus another, and what the crossings are like. Are there crosswalks? Are there signals? Is there a lot of delay in crossing the street? How many lanes do people have to cross? So having a comprehensive pedestrian network lets us do this. We've been working with folks in a handful of states, including Minnesota and California, to improve how they're doing accessibility analysis. And especially recently with folks at Caltrans, we've been talking about how can we build out these pedestrian networks. And in those conversations, we first learned about the work that was happening in Washington. I know folks in California and Washington have been talking. So we were very excited when this opportunity came up to hear directly from those folks today. So I think that's plenty of intro. I think our speakers will cover the rest perfectly well. So I'm going to hand things over to them in just a second. Joining us first is going to be Mary Dubose from the Washington State DOT. Joined the agency in 2024 as the roadside data asset steward. So she's responsible for collecting data on crosswalks and curb ramps and sidewalks and other types of barriers. And also joining us is Kurt Winter, a data analyst with Washington DOT with the Public Transportation Division. He joined the agency recently and has really been focused on integrating accessibility measures into their public transportation plan. Before that, he worked as a data program manager in the Transportation Demand Management and Commute Trip Reduction program in Seattle. And lastly, we've got Dr. Anat Caspi from she's the director and co-founder of the Taskar Center for Accessible Technology at the University of Washington. They focus a lot on accessibility centered on the needs of folks with disabilities. And they run the OpenSidewalks project, which develops, translates, and deploys open source, universally accessible technology with a focus on benefiting populations with motor limitations and speech impairment. So without further ado, I will hand things over to our friends at the Washington State DOT. Kurt, take it away.
Yeah, let me find mute and put the screen up at the same time. Great to meet everyone. Excited to be here. I'm a Kurt Winter. I'm with Washington State Department of Transportation and the Public Transportation Division. I'm joined by Mary, as introed by Chris. Also call out that our colleague Thomas Craig, who's really been instrumental and has supported this work, is in the crowd. He may jump in and do some Q&A support later on. But I'll go ahead and get started. We're here to kind of give an overview of Washington State Department of Transportation's Public Transportation Plan update, how we're integrating accessibility analysis with first and last mile connections. And so I'll start by giving a quick overview of the Washington State transportation policy goals. So this is for the whole DOT, not just public transportation, but essentially these goals are supposed to be woven in and supported by all of the work that we're doing as a division and across the entire DOT. Preservation, trying to maximize the life and lifespan of investments that are made. Safety, continuous improvement, safe systems for all users of the system. Stewardship, increasing system effectiveness, efficiency, and improvement. Mobility, predictable movement of goods and people. Congestion mitigation, economic vitality, supporting, enhancing movement of people and goods and environment, trying to make sure that quality of life improvement and there's healthy communities all across the state. So we do emphasize preservation and safety as priorities, but all across the state and including the Public Transportation Division, we publish metrics and stats on public transportation like hours, miles, ridership, unlinked trips. Some examples of other metrics presented by WSDOT divisions include crashes or road miles or user counts, whether that's car, bike, or pedestrian, and system costs. And these metrics don't directly measure or assess kind of the divisional or departmental goals. How do you compare the value of two different public transportation hours or miles or riders? You can ask which project is the lowest cost per mile or per user, but if not every mile or user is the same, then these get confusing relatively quickly and are not necessarily directly aligned or measuring the priorities. Public transportation agencies complain to us about this, and they are constantly reminding us that these comparisons and using these metrics as the foundation of comparisons is a bit of a misnomer. So our goal is to kind of look at access as a performance metric. We view access as one of the main goals that all transportation systems are working towards. We feel that access is a better performance measure and a direct proxy for mobility and economy, being able to mobilize people and goods, and being centered around people moving more freely is a priority that we think we should be working towards. And it's not just moving, it's not just mobility, it's not just how the average speed that someone's able to move, it's that they're able to get to specific destinations that they need to on any time that they need to. And we feel that that should be a priority. Access can also be used, indirectly to calculate investments, which will yield higher safety and environmental benefits. And kind of in a more mature sense, can be used to calculate projected benefit per unit of cost. So, you get to a dollar amount, which can increase stewardship, where how you're able to optimize and prioritize the system, and in that same sense, where you should be spending time in preservation. So we see this as access to opportunities as one of the best ways for us in the state DOT to implement this process. Access to opportunities is only one way. I'm sure this crowd is very familiar with many different ways to measure access, but we think both with the kind of overlap of technical capacity we have as a DOT, and feasibility and fidelity to the human experience, that this is kind of a good nexus at where our skills, reality, and kind of the scale of the statewide analysis intersect. So I've shared on the right side a screenshot of conveyor analysis. Um, Conveyor analysis is a really flexible front-end application that's built on top of an R5 routing engine. It allows fine-tuning of analysis and aggregating of results really quickly, and kind of you're able to adjust and compare different scenarios in a very, in a seconds to minutes time frame, which is really valuable. And it allows for creating customized routable networks using sidewalks, roadways, trails, etc., and their intersection with GTFS data. So essentially, you can build your own customized network depending on what kind of routable paths you have available to you, and then run the routing model in order to have outputs and comparisons of different scenarios. This view on the right, though, you have a blue origin pin up in the Fruitvale area, and then in a purple isochron, essentially you have the area that's reachable given the transportation network and walking. Within a 30-minute travel window of the current system. And then that's compared with the red isochron, which is a bigger area, and that bigger area is driven by doubling the frequency of access. So essentially, shorter dwell times on bus transfers, shorter dwell time on an initial, uh, getting on a bus. And that's what's represented by the red isochron. And then the black dots here represent the number of jobs in Yakima. So continuing kind of a quick overview of Conveyal and what we're looking at in there. Um, Essentially, along with the map that I just shared, you get some of the data outputs from that. You can see some of the adjustability, and easy variables that you can change uh, within the analysis. So I can adjust travel time. This is again the 30-minute window. You can adjust how well someone's able to adhere to the GTFS schedule. The fifth percentile means that they're really checking their phone and they're getting to the bus stop right as the bus is approaching. 50th percentiles, probably an average user that's showing up at the bus stop and doesn't have the absolute worst luck at catching the bus as it's pulling away. But you're able to adjust things as well, like access mode, the different transit modes available, what date, time, how fast someone is walking, their max walk time, many different variables, so you can run comparisons of what those different things look like within the analysis and see what those outcomes look like. You're also able to run regional analyses and then get a geolocated output for what jobs are available within a given dimension. So instead of having the one origin point, you have a this origin point that's been moved all over the region, and you have how many jobs are accessible within a given 200 by 200 meter square. So this is the example in Yakima. Darker blue represents areas where there are more jobs reachable. Lighter blue represents areas where there are less. And essentially our goal is to execute this type of analysis over the state of Washington to, show where access is strong and where it can use improvement. You can also then, once it's geolocated data, superimpose it and compare and contrast with other valuable data sources that are also geolocated. This is an example of environmental health disparities map that's was an implementation from the Environmental Justice Council in the state of Washington as part of HEAL Act that basically measures what environmental exposures, effects, and socioeconomic factors are in an aggregate fashion. So it has a valuable overlap with our work and is one example of many different geographic factors that we can compare analysis with or accessibility analyses with. So we looked at some past analyses that didn't have pedestrian infrastructure data sets to take anything into account. Chris looked at assuming center road line navigation instead of a sidewalk, and we saw that as a big flaw if we were going to make any assertive statements about what's accessible within Washington. So we saw a major opportunity to improve the fidelity of the pedestrian experience by including sidewalk data in the model. And there's many other ways that this data and application is valuable to WSDOT. And I'll pass it over to Mary to cover a couple of those other use cases.
Thanks. Yeah. So I'll start by giving a little bit of background and context for this. So prior to 2023, we had several agencies throughout the state, each maintaining their own sidewalk data sets, and nothing shared a common schema. Everything had its own set of attributes, method of collection, frequency of data updates. Some areas had overlapping data. Some areas didn't have data at all. If you're a smaller agency, you might not have that capacity for sidewalk data collection. Here at WSDOT, we are responsible for the data set that represents sidewalks along our state routes. Next slide, please. So this is just kind of shows an example of how the sidewalk data can get very messy very quickly. So we've got on these three maps show the same area of North Seattle, North King County, and here in Washington. So on the left, we've got the WSDOT sidewalks along state routes. In the middle is sidewalk maintained by the King County Roads Division, and on the right side is Seattle sidewalks. So kind of along that border between the city of Seattle and the city of Shoreline, you've got a road which kind of sits between those two cities, and it's also a state route. So we could have any given intersection along this road could have curb ramps, crosswalks, sidewalks that are maintained or represented in the data by any of these three agencies. And the data doesn't always sit together, overlap, or snap to each other in the right way. And sometimes it feels like you're comparing apples to oranges when you try to do any kind of widespread analysis. Next slide. Um, so with the I guess prior state of or current state of sidewalk data, we do actively maintain that data for the presence of sidewalks on state routes. We make this data available not only to our own staff internally, but also to the public on our open data site. And we've been using it internally for a few analyses and procedures where we can, such as identifying gaps in the sidewalk network, which helps to know kind of what we have and what we don't have when we're scoping a project. And also tracking investment in sidewalk improvements for the ADA transition plan to know how much money is being put into these improvements and where that's taking place. Next slide, please. And so, thinking to the future, with the statewide sidewalk proviso project that's ongoing, and we now have a finished the first biennium of that project to have this really wonderful sidewalk data set representing not just sidewalks on state routes, but the whole state within our boundaries. So, with that promise of this more complete data set, we have lots of things we would like to use this data for, such as a more robust statewide level of traffic stress. Project or grant prioritization can be a lot more robust. An analysis that I've run before, thinking about sidewalks and routing, is the route directness index. And I ran this previously using the Esri routing engine and kind of just using their pedestrian mode. That is kind of somewhat of a black box where I don't know what exactly it's doing when it does that routing. If we were to build our own routable network, including our sidewalk data, we'd be able to do things like that with a much higher level of accuracy, and we would know exactly what we're getting. Being able to do safety performance and collision analysis, that's a big one. And then, of course, what we're here to talk about today, transit accessibility analysis. And with that, I'll pass that back over to Kurt to talk more about that use case.
Thanks, Mary. So we're in Public Transportation Division of WSDOT. We're developing systems to enable multimodal analysis. So we have a couple different data projects and just an era of data that's converging in the right mix of things that allows us to kind of look at this analysis in this way. We now have roadway and sidewalk data available. Transit service data through GTFS and GTFS Flex is coming online statewide and can feed these analyses. There's also strong fidelity and demographic land use and destination data. So we're looking at it in a public transportation view, but also see the potential to calculate statewide access for all modes, and see access to opportunities as the qualitative framework for the public transportation plan. So instead of emphasizing some of those metrics that we don't feel like are truly representing kind of some of the value of public transportation, are going, the aim is for them to be less emphasized in the upcoming public transportation plan, which will be published next year, and for that to be, a stronger emphasis on access to opportunities. That looks like, building on some of the foundational work other projects have already done by benchmarking access, projecting how much access is the goal, and identifying a cost and timeline to reach that goal within the public transportation plan. So some of the outcomes and what we're thinking this will look like, we're still actively developing, so I'm not going to say these are definitive things, but what does public transportation provide in terms of access beyond just the level of walking? We did some of this analysis in a parks area project that was completed last year. Another valuable comparison is, what access a non-driver has relative to a driver, walking, utilizing different levels of public transportation, and what are folks able to access besides just drivers, and then how transportation benefits are distributed and how much an equitable access level that we feel is accessible would cost. So essentially, we see an opportunity for improved measurements that tie to WSDOT specific policy goals. New data availability has created that opportunity for updated insight. And Sidewalk data inclusion captures multiple needs across many divisions within WSDOT, while also directly improving the fidelity of accessibility analysis. And our goal is to implement access to opportunities as the quantitative framework for the public transportation plan. But there's, a lot of value for comparing and contrasting with other and, all modes. Thanks for your time. I'll pass it back to Chris.
Thanks, Kurt and Mary. Very excited to see what's going on at the DOT there. I'm about to hand things over to Dr. Anat Caspi, who I mentioned runs the Taskar Center for Accessible Technology at the University of Washington, and runs their OpenSidewalks project. Just a reminder for folks, I already see some questions coming in, but feel free to drop more in the Q&A, and I'm sure we will get to those after this presentation. So keep them coming.
Great. Thank you so much, Chris. Hi, my name is Anat Caspi. I'm the director of the Taskar Center for Accessible Technology. Today, I'll be speaking to you about the collection process of this consistent pedestrian infrastructure data at the state scale. And we did manage to do it within one biennium. The objectives, or what I hope you'll walk away with today, is understanding the scale and complexity of doing such a collection, how OS Connect, which is what we call the dataset, leverages AI, schema standardization, and human and automated QA to generate this consistent infrastructure data across a large set of aerial imagery. We want to understand the foundational role of data standardization and a tooling ecosystem that enables this scalable and reusable data tooling, and hope to take away replicable strategies for integrating standardized pedestrian data into planning, routing, and accessibility, just as Mary and Kurt discussed. So I'll open with a little bit of a discussion on the data gap, but Mary and Kurt covered it quite well. We'll talk about our pipeline named Profit and how OS Connect came about, a little bit about the ecosystem and infrastructure that allows us to maintain and update this data. We don't want to just dump and run, and then some outcomes and vision. So I won't cover too much, but the original vision of the work that we were doing is really to focus on the traveler. As Chris had mentioned, we really try to understand the pain points that travelers experience, particularly those with disabilities in the transit environments. And what we found that while we have a pretty good accounting of road networks and the scheduled routing system, rideshare, micromobility are just now burgeoning with new data schemas and standardizations. And what we see here in purple have not yet been schematized widely, and therefore a lot of data is inconsistent in the way that Mary discussed. And so we see that there are many multiple ways where the data gap lives, and we can ameliorate that gap across paratransit, across different transit travel environments, as well as the pedestrian environments. And good data really underpins all these modern mobility tools. So not just the transportation and urban planning part, but also innovative transit applications and new mobility applications, like all the consuming apps downstream. So our aim is to offer this this green layer here that allows for seamless interaction for the travelers with third-party apps, just like Conveil or some other apps that would be able to consume the data at scale. So what is the OS Connect project scope? The area in scope, per our advisory board, was to cover census tracts that allow for coverage of 90% of the state's population. So that was 6,400 square kilometers, plus the densest population centers and transit facilities in the unincorporated areas of the state. So all of that yielded 36,000 kilometers of sidewalks, 6,700 kilometers of crossings, and 134,000 intersections. And we'll see a little bit of what that data is. So when we talk about pedestrian access data, and if some of you are there in the NCB paid current Bureau of Transportation Statistics effort to standardize and schematize this data, you know that there are various tiers at which we can potentially collect these data. In order to scale this at such a large region, we wanted to really understand what would be the bare minimum that we would be able to glean from aerial imagery so that we can have a consistent schematized data set across the whole state, upon which we can provide the tooling for different jurisdictions to build on top of to have their own extensions. So when Kurt and Mary are talking about additional level of traffic stress and things like that, that might need additional tags and attributes, we're enabling to have the infrastructure that allows folks to add on to the data in a powerful way to allow these additional downstream analyses beyond what they have just shown to be perfectly capable of doing with just these main attributes for access. So you see here the main attributes of access. We have 3 entities basically available in the pedestrian spaces. We're designating line work, center line work for sidewalks, for crossings, and those links between them. And we're also designating points that indicate curb interfaces between the shared use space and the pedestrian spaces, and then some additional tags on top of them. Beyond this, we do have tactile paving analysis as well as inclines and width. So the final data that came out of the 2023 through 25 biennium is sized at 11.3 gigabytes. There are these many 533,000 crossings and 534,000 sidewalks. You can see the additional scale of it here. Overall, 7,600 square kilometers of aerial imagery were analyzed. These were made possible by the consistent data set that the Washington State Imagery Consortium collects. And those were made available for analysis and for having this data set available. So what are some of the cost drivers in the statewide collection? As you can imagine, we wanted to understand how much were we able to save in human effort and human years in order to collect this type of data. What we found is that there is large variation across urban, suburban, and rural environments. And so we show a little bit of what the differences would have been across the state and what that translates to in terms of human hours. So if we were to avoid any of the machine learning that was done in order to provide this data set, we would have used 46,000 human hours to cover the area that was covered in this effort. What do we have as our hybrid pipeline? And I want to really highlight that this is leveraging aerial imagery and advanced segmentation models to predict this pedestrian network. But then through the infrastructure that we've built, we have various layers of human validation to correct and enhance these predictions. And so that tooling is also making things a lot faster and more palatable for human eyes to receive this data at the end. The key goal is to demonstrate that there is technical rigor here and reliability of the data sets. So the data validation pipeline has an automated and manual validation checks. There are error correction workflows that identify where to resolve inconsistencies in past connectivity. It identifies where geometries are potentially incorrect and also looks for attribute accuracy. The versioning and data provenance allows us to have timestamped data versions that ensure auditability and reproducibility of these pipelines. So we know over time who made what changes and how were those changes made. And of course, when we turn this over to the state and jurisdictions, they have the same access to that auditing, transparency, and accountability pipelines to understand, how did we change the data from 2024 to 2025, and how can we move forward into a 2026 release and metadata release to have the data provenance indicate like exactly what is in this data and how did we improve it over time. Most importantly, we have an open feedback loop that integrates with a mobile application, and that allows for both community data collections as well as internal departmental data collections on an ongoing update kind of scale. And there are different permissions. So you can allow certain entities, say, with King County Metro, for example, we have a project right now where their internal access to transit team is allowed to make direct changes to the data infrastructure, whereas they want to add community data collection for high schoolers. And of course, that would require a different layer of vetting internally before it gets published. So the idea is about allowing multiple stakeholders different ways of continuous improvement through both public and partner contributions, but making it really transparent and accountable so that we're able to trace these changes over time. So through the use of OpenSidewalks, which is our data schema for collecting this data, it provides a landscape like this that allows these multiple ways of interacting with the data with different skill sets as well. And through the infrastructure that we've built, and this was supported by work through the ITS for us funded us, that's a USDOT project, funded us to build public transportation data exchange, which essentially allows for data sharing in this and multiple permissions set for different entities to interact with the data, as I had mentioned. Essentially, what that infrastructure allows people to do is to collect and share difficult to obtain data. It allows us to support different types of data stewards and demonstrate the impact of equitable data sharing, both within jurisdictions, but also across different entities. So where can you find the data? You can go to our newest OS Connect viewer. It's available. What you're seeing is a screenshot from the OS Connect viewer. Any stakeholder, planners, advocates, community can explore the data sets, suggest edits, download segments, and integrate the data into their workflows. And open participation reinforces quality and fosters the trust in public infrastructure tools. So our objective is really to show that usability and maintenance work together. If we provide the useful and usable tools for stakeholders, then we will be able to maintain and update these data. What we, of course, saw over the course of 10 years that we've been doing this, as Mary mentioned, a lot of times the data is inconsistently collected, and then no one has the ability to interact or interface or maintain it over time. And the worst thing I thought that would be the outcome of this proviso funding would have been if we just created the data and dumped it on the state without useful, usable tools to maintain them downstream. So our dissemination strategy beyond that OS Connect viewer is to have weekly office hours. That's where we have multiple team members from my team on Tuesdays from 8 to 10 a.m. in Pacific to talk about how you might do this in your state, how you can take the data, use it in third-party tools, just like the way that Kurt and Mary did, or perhaps use some of the infrastructure that's already built into the Transportation Data Exchange initiative that I showed here. And just to demonstrate a few other ways of engagement, we have a grant funding program that are called SCLEOs. We just closed off one of the efforts, but another one will come in the fall. And the idea is to fund different agencies to basically learn how to use the data sets and incorporate them into local workflows and pipelines that they have. I will not go, due to time, I won't go into the QA/QC tooling that we've created, but overall, my ideas around QA/QC for pedestrian data have been that they've been inappropriately accounted for, in the sense that you might get information about how, like, the AI tool might have done, or some sample of data accuracy based on some data that was annotated by humans and compared to a data set, but you rarely actually get a sense of how usable is the data. And what is really relevant here is connectivity and completeness. Mary's use cases and Kurt's use cases all rely on the availability of a connected, routable graph network, not just the bean counting ways that we've been able to collect these data in the past. And so what's important is to be able to assess whether the data that we're provided actually provides the connections on the public right of way and demonstrates them in the data itself. Of course, this is a really hard thing to do because we don't have ground truth for a lot of these data. In fact, the ground truth is very sparse. And so being able to approximate this kind of data veracity using different graph methodologies has been what our aim had been. And so our internal tools allow us to do different levels of graph assessments. But beyond that, we're also doing a new type of assessment based on routing. And so that meant that we had to build our own pedestrian routers that take into account pedestrian mobility profiles, meaning we allow our router to assess and simulate the behavior of different types of pedestrians along the public right of way so that we're able to assess where a typical pedestrian walkshed might be, or a wheelchair dependent traveler might be able to reach, and what the disparity across those two different types of pedestrians. So you can see that this type of analysis would allow one to do two types of assessments. One is this access assessment that Kurt was talking about. Another would be a disparity assessment. Where are we potentially disenfranchising some part of the population from access and others are available? And what kinds of projects might that lead us to in order to ameliorate conditions in the public right of way to improve those connectivity for all populations? So as you can see here, we see the walksheds, let's say the disparity between the shared routes and then the wheelchair walkshed routes. You can see that there are potentially some discontinuities in the public right of way along these places. And so what we might do is suggest a new project that would improve connectivity across these intersections. What you could then do is also assess what impact such projects would have. So you would have a business data-driven case for making those changes in the public right of way. And as you can imagine, this connects to ADA transition plans, where a lot of the times it's really hard to prioritize where to put changes in the public right of way when you have 130,000 unramped curbs, but only the funding to ameliorate 13,000 of them, for example. So these are some of the analytics that we are supporting. And in our 2025 to 27 biennium, key goals are to enable additional workflows that help translate OS Connect data into actionable project suggestions, support agencies and communities in identifying these high impact interventions, and the tools to assist with those prioritizations based on safety, accessibility, and aligning local needs and local policy needs, just like those that Kurt opened with potential funding opportunities and planning processes. And with that, I will just let you know that our weekly Tuesday morning happy hours, mappy hours, are found at tinyurl.com OSW mappy hour. And you can, I will skip through all of these. You can visit us at the Seattle Design Festival in August 16 through 17 at Lake Union Park. The theme this year is about feedback, and you will be able to join us for pop-ups about how we actually use these mobile apps to get public interaction and democratize this data at scale. Please let us know and reach out at uwtcat@uw.edu if you have any questions. Thank you so much.
Well, thank you again, and thanks to all of our speakers. In just a second, I'm going to invite all of our speakers back on screen to answer some questions. I know I've got some, but we've got some great ones coming in. So I'm going to just sort of navigate through them in the way that I think makes the most sense. I might start with some more technical questions for Anat to keep the sort of continuity of the discussion. Please, Anat, if you can stop sharing your screen, we can welcome all the speakers back. And we've also got on hand Thomas Craig from the Washington State DOT and Anson Stewart from Conveil. Obviously, there's a handful of analytical tools for doing accessibility analysis. Conveil was mentioned in the presentation, and I know we've worked with their folks a lot, so we're happy to have them here too. I think just to start off, maybe a couple more technical questions, since that's where our head was at just a second ago. I know we've got first just a quick clarifying question. I know you walked through the process. Is it pretty fair to say that basically this whole process starts with aerial photographs, and then from there sort of moves into sort of a feedback loop with QA/QC from there? Is that a pretty good high-level understanding of the process?
Yes.
Perfect. Thank you. I guess building on that, you sort of talked about some of the data needs that go into this. I know a lot of folks are from outside Washington, so I was just kind of wondering your take on replicability of this. So what data can you rely on sort of anywhere that you know you can go to, and what would an agency sort of need to have on hand or start working toward if they wanted to do something like what's been done in Washington?
Yeah, so consistent aerial imagery across the area of interest is what's needed. The best resolution is the 6.5-inch imagery or better. But really, it's mostly needed in dense urban locations. So even if it's not available at that resolution for the rural or suburban environments, that's still sufficient to run the pipeline and move from there. It's really nice to have a road network already present, but that's not a requirement.
Great. Another technical question that anyone can speak to here, and I know it was sort of answered in the presentation, but Lewis Merlin asked about this, who's been working in accessibility at Florida Atlantic University. It sounds like you are incorporating a lot of information about crossings, where just maybe if re-clarify or someone can jump in. What's the extent of that data that's available? Where does it come from? In addition to the sidewalk data, yeah.
Right. So the effort here was really to get consistent baseline data for the entire state. So it incorporates what is clearly visualized through the aerial imagery. So markings or no markings for those crossings. The best curb location that could be assessed through that, so connectivity in the network, and the type of surface and incline of those crossings.
Excellent. I think now I'd like to turn a few questions over to the folks at the DOT. Maybe starting big picture. I know you answered a question in the chat from Eric Lind, who runs the Accessibility Observatory at the University of Minnesota, about reception from within the agency and sort of uh, progress in moving toward accessibility as a sort of holistic measure. I know we've seen variation a lot across lots of different states. Virginia DOT actually uses accessibility in prioritizing projects, but often accessibility analysis is sort of a side project for a lot of folks, whereas the agency is still sort of measuring standard metrics, federal requirements, and things like that. So sort of where is the adoption process in moving towards accessibility?
Yeah, I can try to answer that one. And of course, this is tied up in a lot of different factors of, past institutional practices, politics, et cetera. I think what I would say that the strategies that we are taking, one, piloting, starting small. Testing things out, demonstrating a process, and two, transparency, being clear about there being a possible future direction to this research and the tie-in to transportation policy goals. Revealing that and being clear about that tie-in from the piloting stage and having that conversation in order to take all types of feedback early on. And I guess I should mention a third, which is just getting data in order. There's a number of data sets that we've been working on collecting for a number of years that contribute to this project, that are useful for a wide variety of other purposes. WSDOT Public Transportation Division started supporting agencies in publishing GTFS data, General Transit Feed Specification data at transit agencies back in the early to mid-teens, and then really stepped up that effort in 2020 and 2021. That data has taken some time to collect, to build capacity at agencies across the state in order to be publishing that data. But now, and at that time, was primarily about surfacing public transportation agencies in Google Maps and other online applications. But of course, now that data is useful in this project. So thinking forward, speaking transparently, starting small but moving incrementally forward are some of the ways that we are approaching those large institutional and political concerns that might be raised.
Awesome, thanks. And just playing off that a little, I see a question in here about has this sort of work been used in transit planning yet? What are sort of the visions for how it could be used? Anything from planning new routes to picking projects. Can anyone speak to that? I assume it's still a work in progress given the presentation we just saw, but
Well, actually, in 2024, King County Metro was interested in a deep dive understanding of their transitional housing facilities enabled throughout King County. And so, building on top of the OS Connect data, we added additional attributes that their connected through transit team were interested in. So, as you can imagine, this is the baseline, and then they wanted to add levels of traffic stress and additional understanding of buffers and things of that nature. And in addition to that, there was a clear understanding that the qualitative access that people experience in the public right of way was also an important part of project identification for transit access. And so our team did a two-way approach of both the qualitative approach and the quantitative approach, talking to people to understand how they interacted in these transitional housing facility environments. And building from there came out different projects and prioritization schemas that we are able to score to assess, well, let's prioritize this type of project because more of that population will have greater access to specific services that we were looking at. So that required integrating things like points of interest that King County Metro was focused on as services and community access.
Great. And I was happy to see you have the sort of different set of tools for prioritizing key links in the network, which can be really hard to do with accessibility analysis alone. So that's also exciting to see. I've got a question here well, Anat, you just mentioned level of traffic stress, and Mary, you talked about this a little bit. I want to unpack that a little bit more. Folks may know level of traffic stress mainly from biking, where high-speed roads without protected facilities are more stressful to riders, and therefore they might be avoided or they're considered less useful. I know Washington is one of the few agencies that's sort of developed a pedestrian level of traffic stress. So I was wondering if folks could speak just a little bit about what goes into that conceptually, and then maybe Anson, if you could speak a little bit to what the state of implementation looks like from an analytical perspective in Conveyal at least.
I can give a brief description of level of pedestrian traffic stress at WSDOT. And for this, really, our colleague Grace Young, who's not here today, would be the best person to answer this. But in her absence, I'll give it a shot. So to calculate this specific level of pedestrian traffic stress, some of the features that go into that include things like sidewalk width and presence of a buffer in between the sidewalk and the roadway. So it's helpful, I think, to think about it on two different scales. So doing this type of thing on a statewide scale for kind of a statewide analysis, that would require a level of data that we don't currently have, and that would be like Anat was describing, kind of those add-ons you can build on top of the existing schema to add those attributes. Where it's used more so currently, as far as I'm aware, is kind of at a project level or project scale, where if there's going to be some pedestrian improvements made to a particular corridor, they would look at what do we need to do to bring this up to the level of pedestrian traffic stress that we'd like to achieve.
Yeah, I'll chime in quickly on the LTS question. I think it's really exciting that we might be able to get more widths, like even roadway, having the precise curb locations could get us kind of lengths of crossings, widths, which is something that our kind of more stock OSM inference methods have missed. So I think there's a lot that could happen there. We have kind of basic LTS functionality on the cycling side implemented, but a lot of extensions could come. Just one other note on OSM, I know OpenStreetMap, I know it came up in a couple of the questions. Washington State has uploaded a few test data sets, and we've seen a full accessibility analysis run in Conveyal with the sidewalk layers. So that's pretty exciting. In terms of some additional open source tooling, Conveyal is working on a fresh web-based basic edit and merge tool. So that's open source, still under very early development, but we're hoping that that will streamline a lot of the kind of import process as well.
And I'll just quickly give credit to the Taskar Center and the SLEO grants that Anat mentioned earlier that have supported WSDOT in working with Conveyal to help develop that web-based application.
Perfect. And thank you, Anson, for trying to hit on this slew of remaining questions we have, mostly about OpenStreetMap integration, the availability of open source tools. I don't think we can unpack that here, but the folks on this webinar, I'm sure, are happy to dive in and nerd out if anyone wants to reach out and learn more about what's going on. So with that, I again appreciate everyone's time. This was really fascinating, and we're all excited to see this work happening. I'll just remind folks that recording of this webinar should be available within the week. And if you want to learn anything more about accessibility analysis and other great work that state DOTs are doing, you can visit our website at ssti.us or reach out to me directly with the information on the screen. So finally, thanks again, and I hope you all enjoy the rest of your week.